This one here was a last year past question. It says, outline the synthesis of benzoin using benzaldehyde. And how would you convert benzoin to diol and diketone derivative? Now, firstly, we have to know the reactant we are going to use to react, or we are reacting with. The reactant here is benzaldehyde. So let's draw the structure of benzaldehyde. Benzaldehyde is something like this. You have, okay, we can draw it this way. And then, of course, you have hydrogen double bond O. This structure here is what we call benzaldehyde. Now, for this reaction to be feasible, you have two benzaldehyde that are reacting. So you have another benzaldehyde, all right, that is reacting. But in this case, I'm going to draw this one up. They are still the same thing, no much difference. Then we are going to have it like this. All right, this is another benzaldehyde. Now, this reaction, we need some of these reagents. The reagent that it will need are, we need KCN, potassium cyanate, it will need H2O, and it will need ethanol, CH2OH. And the product of this reagent is what we call benzoin. It's a kind of condensation reaction. It is called benzoin condensation reaction. So this is going to be the product. It's still going to give us a beta hydroxy ketone, or something, not beta hydroxy, more like something like beta hydroxy ketone of that aldo condensation reaction, but not exactly it. So this is going to give us something like this. All right, and then you are going to have C. Here will be H. Here will be double bond. Okay, here we change to OH. Any one of them, you can actually use any one of them. And here we still remain double bond O, H, and then of course, okay, you are not going to have this H here again. Then you are going to have something like this. Now, this entire thing you see here can be shortened. Instead of us writing this diagram, you can just write for this thing as C6, because benzene ring is C6H5. So you can write it as C6H5, and then you have another C, double bond O, and then you have H. Is that okay? So that is what it's going to give to us. Now, that is still the same structure as this, because benzene ring is C6H5, and then you have C, double bond O, and then H. Now, how does the reaction actually proceed? The mechanism of the reaction. The reaction begins with the abstraction of a proton from one of the benzaldehyde. So you agree with me that this one is a benzaldehyde. This is also a benzaldehyde. And this is the product we are expected to form, which is benzoin. Now, let's write. The first step is abstraction of proton from the, what is it called? Not necessarily abstraction of proton, attack by the cyanide. Are you getting a nucleophilic attack by cyanide? You can decide to write it. One, nucleophilic attack by cyanide. But I don't think there is any need for you to write it, but you can write it. Nucleophilic attack by cyanide ion. You know, this potassium cyanide can divide into two to give us cyanide ion and potassium plus, something like this, cyanide ion and this. But this is what is actually attacking. So you write this. I told you that the benzaldehyde can be written as C6H5. Then you have C, double bond O. Then you have H, right? And then you have the cyanide. Cyanide is negatively charged. Of course, nucleophile can attack here because here is partially positive. Here is partially, here is partially positive. Here is what? Partially negative. So when it attacks here, this one will pack up here. So what do you think we are going to form in that reaction? You are now going to form C6H5, C. Here will give us O negative. Here will be Cn. And here will be what? H. Now, this OH here of the alcohol or the ethoxide group can actually come here to abstract a proton from this. right? It can abstract a proton from that, but um I really do not want to use that one. Is that okay? Now this one, it has two resonance form. This particular one, it has two resonance form. One of the resonance form is the one whereby you have what is called a proton shift, where this hydrogen will come here and then this one will come up here. So you are going to form something like this. It's two resonance form, so you use double arrow to represent it. They are the same thing, but what just happened is that there's a shift in proton. So this will give us C6, H5, and then you have C. The proton will come up here to form OH. Here becomes negative, and then you have Cn. This negative charge that you have here now is now a good nucleophile to attack the other benzene ring, other benzaldehyde. Is that okay? This one now is not the one that will attack the other benzaldehyde. So what we are going to do now is just to let me erase this part so that we can have something like this. You know, we have two benzaldehyde initially. One was the one that gave us this. The other one now is the one that will not react. Okay, so what I'm going to do is to write this C6, H5, C, OH, here is Cn, here is negative, plus C, double bond O, C6, H5, H. What is this other one? This is the other benzaldehyde. Told you that this group here, I mean this one here, you can represent it with C6, H5. Alright? So that's what I just did. Now what will happen in this case? This is a negative charge. It's a good nucleophile. So what will happen here? This one will attack this carbon. If it attacks this carbon, this one will come up there. And when it comes up there, what are we going to form? We'll have a negative charge here. True or false? True. So the product will be something like this. Product of this reaction will be something like this. C6, H5, here is C, here is OH, and then we have cyanide. Think, yeah. Are you sure we are not making any mistake? Are you sure? Okay, there's no mistake. I was just too fast forward with my steps. So what is going to happen here is very easy. We are going to have, here will be C, and here there will be a linkage here. So we'll have, you know, this one packed up. Here will be O negative. Here will be H. Here will be C6, H5. And then the last step of this reaction, this particular step, they could actually form, we could say that this step here is reversible. Why? Because there will be proton shift. Now when we talk about proton shift, please take note. What will happen is that this proton, you know, you will have H plus here. This proton will leave here. So what will become here? O negative. And this proton will come here. So what will become here? H plus. So here become OH. Here gives us what? O negative. So that will be the second step of the reaction. And this is going to give us, I mean, the step of the reaction we are currently in. This is going to give us C6, H5. I just pray this place is enough. Here will now become O negative. Why? Because of proton shift. You can decide to put H plus shift. And then here we give us Cn. Here will give us C. Here will now become what? OH. And then of course here will give us hydrogen. Here will be C6H5. Abi? Now at the end of the day, this negative charge here will kick in here. As it's kicking in here, the more labile group, which is Cn, will kick out. So this Cn will no longer be here again. It will go entirely, kick out. So that the final product of this reaction will be something like this, which is, you can just write it as C6H5C. If this one kicks in here, form a double bond here, right? So this gives us double bond O, and there you have C. Here it gives us OH. Here's H. Then you have what? C6H5. Now you see that this reaction and this thing here, they are the same. This is not the structure of your benzoin that you formed, just that it's inverted. What you have here is not what you are having here. All right. So at the end of the day, you call this as the structure of your benzoin. It's very easy. So there is proton shift twice in this reaction. All right. Now have we gotten the benzoin? The next question is, how would you convert it to a diol and diketone derivative, respectively? Now, to convert it to a diol, you can actually react it in sodium amalgam in alcohol. Sodium amalgam in alcohol, that is reduction reaction. If you don't remember the sodium amalgam in alcohol, just say reduction reaction. So reduction reaction can take place. What we mean by reduction reaction taking place is, let me remove all this one here since we've already formed our benzoin. Where is the structure of benzoin that we formed? This is it. So we can take this benzoin, C6H5, C double bond O, COH, H, and then we have C6H5. Right? Now, this particular one now, if you reduce it, I told you that sodium amalgam in ethanol is the reducing agent. In ethanol, the reducing agent. So you can just, if you cannot remember this reagent, just write reduction. So when you reduce this group here, according to what you know in chemistry generally, if you reduce this ketone group, what is it going to give to us? It's going to give us a secondary alcohol. So this is going to give us C6H5COH, and then we have COH. Then of course you also have H here. If you reduce this, there will be one more H here because you are adding how many hydrogen? You are adding 2 hydrogen. Is that okay? That is 2 hydrogen that is being added. So one of the hydrogen add up here, and the other one add up here. And what will happen to the double bond? Double bond will break. There you have C6H5. So this compound is called hydrobenzoin. All right, hydrobenzoin. So this is called the hydrobenzoin. All right. Now, have we gotten hydrobenzoin? The next step now is, how will you convert it to a diketone derivative? Now, for you to have a diketone derivative, you should oxidize. True or false? Because you know, if you oxidize the alcohol group of benzoin, you are going to have the diketone derivative. So this is H5, C double bond O, here will be COH, here is hydrogen, here is C6H5. And then you can just put oxidation without recourse to the oxidizing agent. In case you want to put the oxidizing agent, you can actually use copper sulfate in pyridine and water. Pyridine and water. Even me, this one, I no crammer for head. Are you getting it now? So just remember it's oxidation. By putting in bracket here oxidation, a chemist is supposed to know that you use an oxidizing agent there. So this C6H5, and then you have C double bond O. Here will give us C. This one will be oxidized. Now, in terms of reduction, we reduce this to an alcohol. In terms of oxidation, we now oxidize this alcohol back to what? A ketone. But it's for the benzoin, not this one that we have here. So we oxidize this, and here gives us C6H5. Is that okay? And this one now is what we call benzyl. All right. So basically, that is how to answer this question. If you answer this question, then you are good to go. Thank you very much for your time. We'll see you in the next one.